Descending from the high canopy, the Harpy Eagle catches its prey with astonishing speed and precision. The Harpy Eagle is a swift, agile, and terrifying hunter, perfectly adapted to its environment. Using its keen sight and hearing, the Harpy Eagle carefully scans the dense foliage for potential prey. It can detect its target from a great distance, making it a master of stealth and surprise. This massive bird possesses claws strong enough to crush bone instantly upon impact. It can even lift prey that matches its own body weight, showcasing incredible physical power. As one of the largest eagles, its wingspan can reach over 2 meters in width. These wings are perfectly evolved for maneuvering through the thick, complex rainforest environment. Despite weighing over 10 kilograms, it can fly at speeds up to 80 kilometers per hour. It delivers a powerful blow when it strikes, leaving little chance for its unfortunate victims. If you were a sloth or a monkey in its territory, you would be in grave danger. The Harpy Eagle is widely considered the most powerful of all bird-eating raptors. Beyond its physical strength, this bird is also remarkably intelligent. Its prey, like monkeys, are also highly intelligent, creating a complex evolutionary arms race. The relationship between the predator and its prey is a constant, high-stakes game of wits. Each species constantly adapts its communication, defense, and attack strategies over time. With its legendary strength and hunting prowess, the Harpy Eagle is an unmatched force in the sky. How did nature transform this bird into such a bizarre and effective hunter? What makes it the most feared predator in the rainforest canopy? The first records of this bird appeared in the 1758 book, Systema Naturae, by Carl Linnaeus. He named it Vultur harpyja, inspired by the harpy of Greek mythology. This mythical creature had the body of an eagle and the face of a human. The comparison is fitting, largely due to the unique facial disc of the Harpy Eagle. This disc consists of feathers that form a circle around its face, which it can raise or lower at will. When raised, these feathers direct sound to the ears, located on both sides of the bird's head. It is similar to cupping your hand behind your ear to hear more clearly. This allows the Harpy Eagle to pinpoint prey in the dark, dense rainforest where it hunts. The Harpy Eagle often perches for long periods, completely still and silent, waiting for prey. To help it detect prey easily, its vision has also evolved to be the best of any animal on Earth. The Harpy Eagle can spot very small prey from a distance of up to 200 meters. Its visual acuity and ability to observe detail far surpass human capabilities. To test this, researchers set up a clever experiment. They trained the Harpy Eagle to fly down a long tunnel towards 2 TV screens. One screen displayed stripes, and the other showed a solid gray color. The Harpy Eagle had to choose the correct screen to receive food. They found that the Harpy Eagle could distinguish details 4 times smaller than what we can see. Several features of the Harpy Eagle's eyes make them so sharp. First, The Harpy Eagle has eyes larger than its own head size. They are 1.4 times larger than the eyes of other birds of similar weight. And the Harpy Eagle's eyes are tubular, which helps create a larger image on the retina. This image is then converted into nerve impulses by light-sensitive cells. More cells and less distance between them mean better vision. However, having more cells across the retina is very energy-intensive. Therefore, animal eyes have special central regions with many cells packed tightly. This is called the fovea, providing the brain with the clearest vision of any part of the eye. The Harpy Eagle has a deeper fovea than most animals. This gives the Harpy Eagle exceptionally high visual acuity. For the Harpy Eagle, the highest vision is in its peripheral vision, at 45 degrees to the right and left. It uses this to detect prey at a distance. However, hunters like the Harpy Eagle have something else that most animals don't. That is a second, shallower fovea, allowing sharp vision in the forward field of view. These two foveae allow the Harpy Eagle to see two sharp images simultaneously. This is why you see raptors, like the Harpy Eagle, constantly turning their heads. They cannot rotate their eyes in their sockets. Therefore, these movements help focus the target between the deep and shallow foveae. Having both sharp vision areas is a huge benefit for a bird of prey. However, this also causes conflict with the vision of many other birds of prey, especially those that attack prey at high speeds. When flying fast, turning the head to the side creates aerodynamic drag, slowing the bird down. To solve this, they don't have to fly in a straight line to approach their prey. Instead, they dive in a logarithmic spiral, with their head straight and one eye on the prey. This is especially true for fast birds like falcons or hawks. The Harpy Eagle doesn't fly fast and dive like that, but at 80 kilometers per hour, it still needs aerodynamics. The Harpy Eagle's wingspan is larger than the height of an adult human. They possess a wingspan of up to 2 meters. The female Harpy Eagle is nearly twice the size of the male. These wings are large, but compared to the rest of their body, they are relatively short. How? For example, the Andean condor has a similar weight to the Harpy Eagle, but a wingspan of over 3 meters. This is because the Harpy Eagle was not born to soar high in the sky. Instead, they evolved to move from tree to tree quickly in the dense rainforest. Short, broad wings help them be agile and even allow them to fly almost straight up. Therefore, the Harpy Eagle can attack prey from below as well as from above. Like all flying birds, the Harpy Eagle can fly thanks to the structure of its flight feathers. Unlike other feathers, this part is anchored to the bone, and its main function is to help create lift and thrust. The rest of the feathers are divided into primary and secondary, based on their position along the wing. The longest feathers are at the outermost part and can be controlled individually, like our fingers. They have the role of steering the flight and adjusting lift and air resistance when necessary. For example, if the feathers are raised and spread, the bird's flight speed will slow down and the height will decrease. If the feathers are packed tightly together, the bird will fly faster and more accurately. This ability to change wings is used in different flight situations, helping the bird be maneuverable.
They make human aircraft engineers just watch and dream.
The shorter feathers on the inside of the wing are not easily controlled, but they provide most of the lift by stacking on top of each other to create an effective wing. The tail, or rectrix, is also essential for the Harpy Eagle's flight capability. They have the role of steering the flight, and only the two middle feathers are attached to the bone. In the case of the Harpy Eagle's wings being short, it will compensate with a long tail. Its tail acts like a rudder on a boat to steer through the dense rainforest. The Harpy Eagle's tail is more uniform than the wings. The Harpy Eagle's tail is more uniform than the wings.
And the control part that helps the Harpy Eagle be able to turn is the chest.
The chest muscles are attached to the sternum. The chest and sternum are well developed in birds and much larger than in other vertebrates with backbones, like mammals. But for the Harpy Eagle, this density is even denser. High-flying birds like the Andean condor have small sternums and poorly developed chest muscles. Once birds like them are in the air, they don't have to flap their wings. But the Harpy Eagle, with its short wings, heavy weight, and agile lifestyle, needs stronger flight muscles than any other bird. Beyond this strength, the strength of the Harpy Eagle's feet is also worth noting. The feet of the Harpy Eagle can be as big as a human's wrist. The black, curved claws are larger than those of the North American grizzly bear. With a length of up to 13 centimeters, the Harpy Eagle has larger claws than any other bird of prey and can exert pressure of over 50 kilograms on its prey. These claws are known to be able to break the victim's bones instantly, or grab prey from the tree with a force stronger than a large dog's jaw. Just the cold, chilling hunting ability is enough to cause terror in the subconscious of primates or sloths. But above all, the Harpy Eagle is very smart. They hunt the most intelligent prey in the South American rainforest. And that is one of the most interesting, unique, and exciting arms races between predator and prey ever observed. In the survival battles of the animal kingdom, the predator needs to catch the prey, and the prey needs to do everything to avoid being caught. These simple phenomena have led to a spectacular phenomenon. Predators and prey around the world are locked in evolutionary races. One example of this is the race between bats and moths.
This arms race began when bats developed the ability to navigate by sound.
To detect moths in total darkness. To respond, moths evolved ears that allow them to hear the sound emitted by bats.
And take evasive action.
After that, some bats improved their hunting strategy by developing the ability to navigate by sound more subtly. Specifically, navigating by sound at frequencies that moths cannot hear. Specifically, navigating by sound at frequencies that moths cannot hear, which they can use to defend themselves in an attack. And this back-and-forth development can be seen across the animal kingdom. However, for a long time, people knew relatively little about how meat-eating animals hunt primates, and how intelligent primates counter that hunting. Therefore, researchers started a study to observe. Although the experiment was somewhat violent. Barrow, Colorado Island is a biological reserve in the middle of the Panama Canal. This is the habitat of many primates, including squirrel monkeys, spider monkeys, and the most important species in this study, the howler monkey. On the island, there are over 16 groups of howler monkeys, and each group has nearly 20 individuals. Usually, primates develop calls specifically for meat-eating animals. Calls to distinguish between large cats, snakes, and eagles to warn their peers of specific dangers nearby. And take defensive measures. However, for 100 years, howler monkeys on Barrow, Colorado Island have not faced any large predators. No jaguars, few snakes, and most importantly, no eagles.
Until 1999, when 2 Harpy Eagles were introduced to the island, monitored by wireless signals brought by humans.
Researchers wanted to know if the monkeys on Barrow, Colorado Island could organize a response to a predator they had never seen before. And if they were surprised, how long would it take to come up with a counter strategy? As predicted, after the Harpy Eagles were released into the wild, they caused terror for the monkey group. Each Harpy Eagle caught a howler monkey in 3 to 4 days. And at this time, the monkey group had only one of 2 reactions to the Harpy Eagle's attack. They would act in a panic and random excitement, without any coordination between the monkeys.